Now this video is talking about covalent bonding and the types of covalent bond. A covalent bond forms when you have two individual atoms that share two or more electrons between them. And typically covalent bonds only occur between non-metal atoms. And covalent compounds are called molecules. So I never really refer to covalent compounds as compounds. I usually say molecules. So here's an example. Here's hydrogen molecule. You have two hydrogens and they're sharing these two electrons. Now covalent compounds can be solid, liquid, or gas at room temperature, and they form molecular units, so molecules, and are made of nonmetals. Covalent bonds is the sharing of electrons, and there are several electrostatic interactions between these bonds. The first is going to be the attraction between electrons and the nuclei. So here's the electrons, and here's the nuclei, and there's going to be attraction between them. And now since like charges typically repel, the other is going to be repulsion between the electrons and then repulsion between the nuclei. So let's go ahead and talk about the types of covalent bonds. It all deals with the electrons being shared in the bond. And if you guys notice what I said here, electrons are not always shared equally. And let me go ahead and show you an illustration. And if you look at this, you'll notice I have two molecules. First one is a diatomic molecule, fluorine, and then I have HF on the right side. Fluorine here looks like it's equal sharing. The reason why it's equal sharing is that the electron cloud densities look about the same. Okay, but if you look here in the HF, it's not quite the same. You see that this side is much larger than this side. And the reason to that is that fluorine is pulling harder than the electrons that it shares with hydrogen. And so ultimately, the fluorine is going to have a larger electron density. And this deals with electronegativity, something that we learned back in periodic table trends. And there is a name for each type of covalent bonds. This is called nonpolar and this is called polar. So in the next couple of slides, let's go ahead and talk about how to determine whether it's a polar or a nonpolar bond. Now, the two types we're going to talk about, the names of the two types is nonpolar and polar covalent. The first one we're going to talk about is, so let's go ahead and talk about the first type of covalent bond, a nonpolar covalent bond. This is where you have the electrons equally sharing between the two atoms. And so here's the fluorine. This is the fluorine model, and you go ahead and write this in your notes packet. And if you notice, here is the electron cloud, and it is evenly distributing amongst the two. Each of these black dots is the nucleus of each fluorine. Now, you will also have a table, and the table that you have on your sheet looks like this. And so one thing you need to know is that a nonpolar bond, a nonpolar covalent, when we take the difference, and it will be between 0 and 0.3. We'll do some practice in how to determine the type of bond later, but right now I just need you to know that the electron difference for a nonpolar covalent is between 0 and 0.3. So let's go ahead and talk about polar covalent bonds. Polar covalent bonds is a unequal sharing of electrons, and because there's unequal sharing of electrons, you form what is called a dipole. And a dipole basically is similar to a positive or negative charge in an ion, but for us it's not a true, so we call it pseudo charge. And so if we look at this example right here, here is HCl. It is very similar to HF example we had in the previous slides, but difference is you're just using chlorine. And if you notice, again, the chlorine has a larger electron cloud than H, and that's because the electrons are being pulled towards the chlorine, and therefore the electron density around chlorine is larger than the electron density around nucleus of hydrogen. How do we determine the type of bond? Well, for polar, you have to know that if we take the electronegativity difference, the difference should fall between 0.4 and 1.7. If it falls above 1.7, it's considered an ionic bond. So let's go ahead and talk about these electronegativities. Now, one thing you guys need to remember, electronegativity increases as you go across a periodic table and decreases as you go down. So the closer you are to fluorine, the more likely you have a higher electronegativity. So that means you have a stronger pull, okay? So if you have the stronger pull, you're going to be the one that's indicated with a delta minus. So anytime you have a large electronegativity between the two you're comparing, that's the one that's going to be indicated as delta minus. All right. So let's summarize this up. So on your notes, you should create an electronegativity line. This is just basically telling you where we're going to find the types of bonds. So the first one you guys need to write is that between 0 and 0.3, you are going to find a nonpolar covalent. Between 0.3 or 0.4 and 1.7, you are going to find polar covalent. Anything higher than 1.7 is going to be ionic. So, general rule of thumb, the larger the number, you're going to be increasing in ionic character. So let's go ahead and do a couple of practice questions. So let's go ahead and look at HCl. HCl, if we were to do this problem, we need to look at the electronegativity chart. And I will always give you an electronegativity chart on your test, your quiz, or your homework in order for you to determine the type of bond that we're looking for. So let's try out HCl. So here's H, okay, and it has an electronegativity of 2.1 and Cl of 3.0. When we are looking for the character, basically you're going to take the absolute value of the difference of the electronegativity. So 2.1 is electronegativity of hydrogen, and chlorine is 3.0. When I take the absolute, I end up with 0.9. This tells me, if I look at the chart, this falls under polar covalent bond. So this is a polar bond. Now the next thing we need to do is write the partial positive and partial negative. When we're looking for who to write that delta minus or delta plus, basically you just have to look which one has a higher electronegativity. Well, 3.0 is the higher one, and so that belongs to chlorine. So I'm going to go ahead and write the delta minus under chlorine and the delta plus for hydrogen. Okay. So let's go ahead and now try another one. CBr4. So when we're looking at this, many people are always looking at this 4, and they think we have to multiply this by 4. No, not really, because what we're looking at is the individual bonds. When we look at it, this is actually just one carbon bonded to one bromine, and that's what we're looking for. So when we go ahead and determine whether this is polar or nonpolar, we're just going to go ahead and look them up. So here's bromine, 2.8, and here's carbon, 2.5. So all I do is take 2.5, the absolute value of 2.5 minus 2.8, and this is equal to 0.3. If we look on our chart, this falls under nonpolar. So this is a nonpolar bond. Because this is a nonpolar bond, I will not put a delta plus or a delta minus. So underneath here, I shouldn't be seeing delta plus or delta minus. So the final example that I have for you is going to be hydrogen and oxygen. So hydrogen has a 2.1 and oxygen is 3.5. So again, even though there are two hydrogens, you're looking at the single H O bond, okay? And so hydrogen is 2.1 and oxygen minus 3.5. And it's the absolute value. So you should end up with 1.4. And this falls in our polar category. Now that we know that this is a polar bond, I can go ahead and write the delta minus and delta plus, which are the partial negative and partial plus. Oxygen is 3.5 and hydrogen is 2.1. So since 3.5 is larger, that means the delta minus belongs underneath the oxygen, and the delta plus belongs underneath hydrogen. Okay, so now you have a worksheet that you need to complete. If you have any questions, feel free to ask in class, but this should be self-explanatory. If you have issues, just watch the video again. All right,